Hi, everyone. All right, we're going to start Module 5 now. All right, elasticity. All right, elasticity is a measure of how much one variable changes given the change of another variable. So this relates primarily, for our purposes, to supply and demand. How much does quantity demanded change? Remember, the law of demand says that as price goes up, quantity demanded comes down. Well, how much does quantity demanded come down when price goes up? Vice versa is also true. How much does quantity demanded rise when price comes down? That is what we call elasticity of demand. You could argue the same thing with supply. Remember, law of supply says that as prices rise, quantity supplied rises. By how much? Just how responsive are producers to a change in the price? Okay. There's also something called income elasticity that we're going to talk about today. Income elasticity is a measure of how responsive consumers are to changes in their income. How much more will they be spending given a pay raise? All right. And then there's cross price elasticity of demand. So you will recall from chapter 3 that there are complements and substitutes. Well, cross price elasticity of demand is a measure of how much does demand for one good change if the price of its complement or substitute changes. Okay, let's go back real quick and talk about income elasticity. Income elasticity will also tell you whether the good is a normal good or an inferior good. So those are important ones as well. So those are the big four that we're going to deal with in here. And really, elasticity applies to anything. Again, it's the general responsiveness that of one variable to changes in another variable. So there's, how about elasticity of labor? How responsive is labor to a change in wages? That kind of thing. All right. So there's all kinds of ways that the idea of elasticity can be applied. We're going to focus on these four today. All right. So elastic demand. Demand is said to be elastic when quantity demanded changes a lot when the price increases or decreases. All right. So it's a high responsiveness of quantity demanded or supplied to changes in price. It should not say or supplied here because they're talking about elastic demand. So it's not quantity supplied. It's only quantity demanded. I apologize. First time I've worked with these slides, as you'll recall. All right. So in elastic demand, then, of course, is the opposite. It's low responsiveness. Cigarettes generally are relatively inelastic. Fuel is relatively inelastic. Even though it gets more expensive, you still got to fill up your tank from time to time. You may decide not to go on that family outing to grandma's house, but nonetheless, you're still going to need to be able to get back and forth to work, take your children to school, church, whatever other functions you have maybe going on in your life. All right. All right. So what are some of the factors that predict product demand and whether or not it is elastic or inelastic? Well, if there's lots of substitutes for a good, you can believe it's pretty elastic, right? So, for example, there's no real alternatives to putting gas in your car. I mean, you can buy an electric car. I have a hybrid I just got a couple months ago, a Kia Niro hybrid. It's a self-charging hybrid. It's not a plug-in. It's about 45 to 55 miles, probably about 45 to 50 on average. And about a 4.5 hour tank of gas, which is not bad at all. But other than that, there's no real substitutes, right? I mean, if you're having a hard time affording to fill up your tank, it's going to be a hard time to go buy a new car, right? So there's that issue. Substitutes, lots of substitutes. But on the other hand, if you're a smoker and your Marlboro cigarettes get more expensive, well, maybe you'll switch your consumption preference to another brand. That kind of thing, right? Lots of substitutes. Or maybe you'll go to those vaping things. I don't know much about that stuff. I'm an old fogey. All right. There's also the issue of whether it is a necessity or a luxury, right? This certainly will impact income elasticities. Income elasticities will give you some idea about this as well. But if it's necessary, it's going to be relatively inelastic. If you're addicted to cigarettes, that's why they're relatively inelastic, because there's an addiction component there. right? But if it's a luxury, going out to eat frequently, well, you can buy food from the home for the home. That's something that you can forego some of and save some money by buying groceries, that kind of thing. Right? Share the consumer's budget. Again, certainly income elasticity is going to affect this, but also just how much does this particular good or service whose elasticity you're trying to determine or have some idea of, just how much of your budget does that particular good consume, right? Going back to my example with fuel, it's relatively inelastic, but at the same time, that doesn't mean that there's not any, that you couldn't cut back on some driving, because filling up your tank too frequently is just going to eat too much of your budget up, right? So then there's you've got to consider short run versus long run. This becomes more important later on in the semester. This idea of short run and long run is really important. And then there's the competitive dynamics, which really comes down to substitutes. That's what substitutes are, right? Competition. All right. So which of these have elastic demand and which are inelastic? Well, as I said, gas is fairly inelastic. I suppose coffee is relatively inelastic. Medical procedures are pretty inelastic. Now, there's a different distinction to be made, right? Between, those procedures that are necessary for the sake of your health, and then those that are more cosmetic or a preference, a thing that you want to have done. That's not necessarily, maybe removing a mole, I don't know. But something like that. Those are not as elastic, or those are not as inelastic. All right? So, most of the rest of these, I would say, are pretty elastic. College textbooks, kind of in the middle. You're certainly always looking for alternatives, aren't you? Renting used copies, still pretty expensive. Coffee, again, there's a little bit of an addiction element here, right? There's some caffeine is something that some argue is addictive. So maybe that makes coffee a little bit more inelastic than some of these other goods. But I don't think it's all that inelastic, right? Probably somewhere in the middle. Airline tickets, again, are you buying tickets to go visit family and just travel and vacation, or are you buying tickets because you have it for work? That's going to determine the level of elasticity, right? The context in which these purchases are occurring. Concert tickets, generally speaking, that's going to be pretty elastic, all right? As tough as it might be to imagine, you can get by without those concert tickets. Soft drinks, same thing, right? All right. All right. So here again, elastic demand, when the calculated elasticity of demand is more than one. So when you're talking about elasticity of supply or elasticity of demand, you are talking about an inflection point that's at one. Elastic demand is more than one, inelastic demand is less than one. All right? And it's important to understand that you really want the absolute value here. You do not just drop the negative. All right? Just when you're doing your calculation, take the absolute value of your answer, and if the absolute value of your answer is more than one, it's elastic. If it's less than one, it's inelastic. All right. So inelastic demand is basically what you're saying is a 1% increase in the price paid by the consumer leads to less than a 1% change in the purchase price, right? Or the quantity demanded. And so that's pretty low responsive. And there's inelastic. The same with supply, right? When the calculated elasticity of either supply is greater than one, then you have elastic supply. Inelastic, again, if it's between 0 and 1, if the absolute value of your calculation, and we'll get to the formula for elasticity in a moment. That's why I keep saying your calculation. I apologize if that seemed out of context. There is a way of calculating this literally, mathematically, if you didn't catch that in the PLA. A 1% increase in the price paid to the firm will result in less than 1% increase in production. Law of supply means those two move in the same direction, but how much? 1% increase in price doesn't lead to as much of an increase in the supply as might otherwise. All right, there's a couple of different ways of calculating elasticity. There's the midpoint approach, right? And this is most accurate, and we will see this one, right? And that's when you're taking the growth rate or the percentage change in quantity demanded and dividing it by the two quantities being demanded. So we'll look at that in a moment. There's the point elasticity approach, which is an approximate method. So we will take a look at that. And then unitary elasticity, if your calculation comes to 1, it's unitary elastic. Okay? We'll talk about that in a moment. So here's the basic formula for elasticity of demand, right? It's a percent change in quantity. Percent change in quantity. They have their own way of showing you percent change, and you're going to have to be able to do this for the test. I'm going to give you my sort of standard way of calculating. When we talk about percent change, we're really talking about growth. And growth can be positive or negative, right? So it doesn't have to be some increase in it. But it's always a percentage, and it's calculated by taking your new number, subtracting the old number, and dividing by that old number. And you want to multiply that by 100 to move that decimal out. And you will get your new minus old divided by old. Multiply by 100 to slide that decimal point out and convert it to a percentage. That's percentage change, okay? So if they say that the quantity demanded went from 36 to 42, well, that's a change of 6, but that's not what we asked. We wanted to know what's the percentage change. So that's going to be 6 divided by 36, all right? And that's your percentage change. Multiply that by 100 to slide that decimal out 2 places to convert it to a percentage, okay? But you don't convert to a percentage till you're done. So you don't use percentage calculations in most typically. So be aware of that. Okay. So in this case, for every 10% increase in the price of a pack, you can do it here because you're dealing with nothing but percentages. But you could also convert this to a decimal and say 0.07 divided by 0.1 and get the exact same calculation. Not a problem, right? But since they're all percentages, you don't have to worry about that as much, right? So for every 10% increase in the price of a pack of cigarettes, the smoking rate drops about 7%. So again, using that formula, -7, because it drew, demand's always going to produce a negative number. The elasticity of demand will always be a negative number. And that's because as law of demand says as prices rise, quantity demanded falls. So one of those numbers is inevitably going to be negative. And a negative divided by a positive or positive divided by a negative is going to produce a negative number. There's that absolute value. So to calculate this, you don't know what -0.7 is. Take its absolute value, 0.7. It's inelastic demand. And that's what I said about cigarettes to begin with, right? Cigarettes are relatively inelastic. And here we have the mathematical calculation that shows that when you increase the price of a pack of cigarettes by 10%, which can be done using what we call an excise tax, we'll talk about that towards the end of this section, this module, then it only is going to reduce cigarettes by 7%. So, all right. Now here again, negative sign reflects the law of demand. At a higher price, quantity demanded for cigarettes is going to decline. There's no way around this calculation producing a negative number. So, what you want is to take the absolute value of that, and it'll tell us about that in a moment. All right, so the size of the quantity is less than the size of the change in quantity is less than the size of the change in price. All right, so take a relatively large increase in price to cause a significant decline in consumption of cigarettes, which is the challenge we face. Right? Consumer responsiveness is relatively small when the elasticity is less than 1. Demand is again inelastic, as we talked about. All right. If the absolute value of the elasticity of a product is greater than 1, the change in the quantity demanded is greater than the change in price. That makes it elastic. If elasticity is equal to 1, it means the change in the quantity demanded. And I should say again, if the absolute value of the elasticity is equal to 1, it means the change in the quantity demanded is exactly equal to the change in price. So the demand response is exactly proportional, right? And we call this unitary elasticity, right? Unitary means 1. All right. So here's their calculation for growth rates. Change in quantity divided by quantity. The only reason I don't like this is you don't know, some people may not intuitively understand which quantity to use. If you only got 2 quantities, how can you find out what the change in the quantity is? All right? And so I do new minus old divided by old because that tells you which one to use. You're going to have a newer quantity. So if you'll look over on the bottom right where it says use the point elasticity approach with product quantity demand at 100, then move to 103. Well, the newer number is 103. Subtract 100 from that, and you're left with 3. You divide that 100. That's where the 3% change comes from. In the example on the left, a job pays $10 per hour. At some point, the individual doing the job is given a $2 per hour raise, so the change there is 2. The old number is 10. The newer number will be 12. So now we've got 10. 2 divided by 10 is 1/5 or 20%. All right. So the midpoint, also sometimes referred to as arc elasticity, uses the average price and average quantity over the price and quantity change. So that requires a little bit more of a calculation. So really the best way to do that is let's see. So we will get to a good formula for this. I have it written down. We'll get there in a second. So what we want to do is I left something off. I was worried about that. Give me just a quick second and I'll show you the formula for arc elasticity or midpoint. All right. So this is what we're talking about. If you don't recognize some of that, I will explain that to you. That is 1/2. That next symbol there means a summation, right? That's a summation. And then that triangle there means change. So you're taking half of the change in quantity and dividing it by half the change in price. That is effectively what we are doing here. All right. That is your basic arc formula, your midpoint formula. All right. So going back to that example with 103 and 100, to be more precise in the calculation of growth, we said 3%. But in fact, if you will, well, I'm still missing a part of this. So hold on just a second. I want to be sure that we get this right. All right, so really what we're talking about here is the change in quantity divided by 1/2 the sum of quantity divided by a change in price divided by 1/2. Sorry, it's been a while for me. So here's the new and improved formula. All right, pause that and write that down. What that is saying is the change in quantity divided by 1/2 the sum of the two quantities. That's going to be what goes in my numerator. My denominator is going to be the change in price divided by 1/2 the sum of the prices. You see that? That is my, in this case, we're going to call that, it's really, I could just do epsilon by itself, but let me put that equal sign there. So we use that epsilon character, that Greek letter epsilon, and the sub D there is for demand, but it could be supply too. And this will be similar across all elasticities. You can always use this method. It may not be Q and P. It may be P1 and P2 in the case of a cross price elasticity. It may be Q and I in the case of an income elasticity, that kind of thing. So keep that in mind. W and L in labor elasticity, that kind of thing. All right. So, but that's the one that you want. Ignore that first one that I showed you. I apologize. All right. But that's your midpoint. Okay. So they subtract 103 from 100, divide that by 1/2 of the sum of those two. Half of 103 is 101.5, and so the growth rate is, on average, over that time frame, is closer to 0.96. Is a more accurate rate of growth. All right. So there's the percent change in quantity divided by the percent change in price. That's how they're doing it. That's fine. So I used some mathematical shorthand. So if that's better for you, if you like that better, you're not comfortable with the math shorthand, write that down. Pause this right now and you can write that down. And keep in mind that that top one, that price percent change in quantity, is going to be divided by the percent change in price. All right, that's how you're going to calculate elasticity of demand and or supply. Okay? All right. So again, percent change in quantity divided by percent change in price. So in this instance, we have price decrease from 70 to 60. So our price decrease is going to be negative 10. All right. And that you see that here. So, and at 70 here, let's see, is 2,800. Yep. And then at 60, it's 3,000. Okay. So what you're going to want to do is, again, calculate percentage change in quantity. That's this horizontal axis here, and that is going to be my first value in the coordinate pair. And we're at 70 and 60, so we are here and here. This is where we are, right? Here and here, okay? And so went from 70 to 60. It went from 70 to 60, right? And so it went from 3,000 is the new number, 2,800 is the old number. You subtract those, you end up with 200. All right, there's your difference. But now you got to do this right here. 5,800 divided by 2 is 2,900. 200 divided by 2,900 times 100 is 6.9. The change there is 6.9%. All right. And then for price, went from 60 to 70, negative 10. The sum of that is 130 divided by 2 is 65. Negative 10 divided by 65 is negative 15.4. All right. One of these is guaranteed to always be negative when you're dealing with demand. All right. And this is a downward sloping curve. Quantity and price, this is demand. Okay. And so now we've got 6.9 divided by 15.5, negative 0.45. Take the absolute value of that, 0.45, and we are being told now, we can make this, we can say with all honesty that demand is relatively inelastic. Now you'll notice that the slope of the demand kind of tells you this, doesn't it? I mean, that's really what we're measuring, is the change in the rate of change, the rate that the demand is changing, quantity demanded is changing, right? Given that price. And so I guess that's what it would look like to you, right? There's the downward sloping curve, and the flatter that is, the more inelastic demand is. And as you go up and up and up and up, the more the more elastic demand is. And so the fact that this curve is relatively, it's not at a perfect 45-degree angle, it's lower than that. That tells me that it's relatively elastic. Okay. Elasticity is not slope. It's not really true. Slope gives you some idea. The reason for this is because even though it's a linear function, elasticity is going to vary over different prices. I mean, for example, remember one of the determinants of whether it's elastic is just how big of a chunk does it take out of your personal budget. Well, at $50, it may take a lot, but what if price falls to 10? So at $50, a change in the price is not going to have a huge effect on demand. But at a price of $10, it might. You go from $10 to $8, that may have a bigger effect on quantity demanded than price, and that at 50 going from 50 to 48. See what I'm saying? And so that's the point they're trying to make here. But at that point where you're at, it is absolutely the rate of change of that demand curve or supply curve, and that is absolutely the slope. So I get the point they're trying to make here, and that's fine. But for our purposes, it's okay to consider it slope. They're being in my opinion, they're being a little too cute by half, right? They're being a little too self-righteous. It's not necessary to be quite so explicit. So price elasticity is going to change over the curve. The higher you go, the higher you go up on a demand curve, for example, that means quantity is getting less and less and price is getting higher, the more inelastic it's going to become. The more elastic it becomes, right? And as you move down to lower prices and less quantity, or more quantity, then then it becomes more inelastic. Okay. So elasticity changes even along a linear curve. I know that seems oxymoronic to call it a linear curve. Right, so relative elasticity is that percentage change in quantity demanded greater than the percentage change in price. Right, so it'll be more than 1. The absolute value will be more than 1. Relatively inelastic means that the percentage change in quantity demanded is less than the percentage change in price. Right, so it'll be less than 1. Its absolute value will be between 0 and 1 if it is inelastic. Right, then again, there's that unitary elastic, which means that a 1% increase in price is going to change quantity demanded or quantity supplied by exactly 1%. Boom. Okay. There's this idea of perfect elasticity, and it's not really a real thing, but it means that when quantity can change by an infinite amount in response to any change in price, it's not going to matter. And that would be if your demand curve is perfectly horizontal, you have perfect elasticity. Not really real. You can also have perfect inelasticity, right? A good can be perfectly inelastic, arguably, at least theoretically, and that would be a perfectly vertical supply or demand curve. And when it is perfectly inelastic, the only example I can really think of might be life-saving medication, insulin, that kind of thing. Doesn't matter how much it costs, you got to have it, no matter what. You could argue that's perfectly inelastic, right? But all right. Kind of reviewing the exact same thing we've already talked about. Okay, same thing. All right, here's a nice table that kind of summarizes it. I would certainly recommend that you take advantage of something like that. Okay, that's a good way to summarize. Elastic, computed elasticity is greater than 1. Inelastic, less than 1. The absolute value is less than 1. Right? So the way you might want to do, especially at least elasticity of demand, is put some absolute value bars around it so that you'll know that you need the absolute value. All right. All right. Again, epsilon is often used, and again, notice that it becomes increasingly elastic as you move up as quantity demanded, as price rises, the demand for goods become increasingly elastic. In other words, consumers are going to be much more responsive to a change in the price when prices are already high than they would be if prices were lower. It's a little less elastic as you move down. All right? And that's why they say, be careful, don't use a slope, but blah, 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 blah. So, all right. Again, 2 extreme cases, perfect elasticity on the left, perfect inelasticity on the right. Really aren't, these are more theoretical cases, okay? This elasticity would be 0, and this elasticity would be infinite or undefined, depending on how you want to do it, because your denominator would be 0, and you can't have that. Price elasticity of supply, again, it measures how much quantity supplied changes in response to a change in price. How do producers respond when the price changes? Right? That's the difference between supply and demand. And remember, law of supply says as price rises, quantity supplied is going to rise. So by how much, though? Just how much? How responsive are producers to a change in the price? All right. So here's a much more realistic supply curve. You can also take slopes of nonlinear curves, can't you? Anybody take calculus yet? It's called the slope of a tangent line. Take a line that touches this curve at one point, and only one point. Don't go through it. Just touch it, like right here, something like this, right? And you can take the slope of that line, and at that point, that is the slope of the curve. You take the derivative of the function at that point, you'll find it. Right? So, for those of you who have done calculus, you probably have already seen this before. All right. nothing much more there. Apartment rents for $650 per month at that price, 10,000 units. Right here, 650, 10,000, thousands of rental units. When the price increases to $700 per month, then they're willing to make 13,000 units available. And what is the price sensitivity? Well, do they do the calculation? It looks like they do. So here again, using elasticity of supply, no need to worry about absolute values because they're going to be, I guess you do if they both are changing. If there's a decrease in price, there'll be a decrease in supply. You'll have two negatives, but that's going to turn out being positive anyway. So it'll be elasticity of supply is always going to be positive, so we don't have that problem. But looking here, it looks like the difference. We went from 10,000 units to 13,000 units, right? So we're going to have 3,000, which is the difference, divided by the half the sum of them. So half of 23,000 is 11,500. Someone correct me if I'm wrong about that. I'm going to drop 2 zeros so that I'm to make it a little easier to do 330 over 115. All right. And I'm going to divide that by a similar calculation when it comes to price. Went from 650 to 700. The difference there is 500. All right. And then the sum of those is 1350. Half of 1350 is 675, I think. So let me know if I did that wrong. Then you take that calculation, right? You take 500 and divide it by 675. So let's see what they did. Let's see if I'm right there. Yeah, through 30 over 115 or 3,000 over 11.5. And then I said 500, didn't I? And it was 50. 650, 700. I don't know why I thought 500. I'm sure some of y'all were like, oh, you screwed up. Sorry about that. Thank you. 50 over 675. But you get the idea. The calculation is roughly the same. And then you got 26.1 for the percent change in quantity and 7.4% change in price. And so you end up with an elasticity of, this should be price elasticity of supply, not demand. A typo in their slides, not mine. I apologize. I make plenty of mistakes all myself. I don't need theirs. But that's 3.53. Clearly, we have a pretty elastic supply here. Pretty elastic supply. In fact, it looks like they want to, for every 1% increase in the price, they want to increase production by 3.5. All right. For every 1% increase in price, they're going to increase units by 3.5%. Okay. So you can measure elasticity using any determinant other than just the price, right? How does a percentage change in one variable cause a percentage change in another variable? There's your elasticity. It does not just apply to the responsiveness of supply and demand to change the price. Quantity demand also depends on income and taste and population. You can calculate elasticity based on population. How much does demand change? How responsive is demand? How responsive is quantity demanded to a change in the population? Right? You can calculate these things. So here we have income elasticity. Income elasticity demand is going to be positive, and it's percentage change in quantity demanded divided by percentage change in income. Right? A rise in income will cause an increase in quantity demanded of normal goods and will cause a decrease in the quantity demanded of inferior goods. Yeah, they're not saying that right. An increase in income, an increase in your income will cause demands for normal goods to increase, not quantity demanded. There's a difference that we talked about in Chapter 3, and they're conflating the two here. I suspect this was thrown together by a grad student who probably, respectfully, has no business being a grad student, because that's just not right. All right. So an increase in income will cause an increase in demand for normal goods and a decrease in demand for inferior goods. And so, yeah, there's the inferior. So when you calculate your income elasticity of demand, if it is negative, it's an inferior good. If it's positive, it's normal. For both income and cross price elasticity, my inflection point is now 0. We're going to be saying if it's positive, it's 1. If it's negative, it's the other. In this case, if it is negative, then if you calculate income elasticity, if you're trying to measure how much does my demand for this product change given a change in my income, and that calculation comes up negative, the reason for that is because the good is an inferior good. All right, and this is important again, because if your income goes up, you're not going to buy as much of those cheap inferior goods. You're going for the normal goods. So if the income elasticity calculation is positive, you know that the good you're looking to see how much demand changes based on change in income. If it's positive, then it must be a normal good. It's not inferior. And when incomes go up, people will buy more of that one. Okay? And here's cross-price elasticity. This is the idea that the price of one good is affecting the quantity demanded of a different good. So the easy way to remember this one here, negative is inferior. Makes sense? Positive is normal. All right? So cross-price, there's not going to be an easy way to remember this, but complementary goods have negative cross-price elasticities. And substitute goods have positive cross-price elasticities. All right? So, and in this case, you're looking at if good A is a complement for good B, then as the price of B rises, demand for A is going to fall. If goods A and B are substitutes, then a higher price for B will mean a greater demand for A. Okay? So keep that in mind. And here's that calculation. So, and this is specifically for if you're wanting to know the cross-price elasticity demand for the quantity of good A that is demanded as a result of percentage change in the price of good B. All right? So you're looking at how much does good A change, the quantity demanded of good A change when the price of good B changes. And this is, again, is somewhat confusing because really good A, it's not the quantity demanded that's changing, it's demand. But that specific point on it, when that has happened, there is going to be, we're arguing over finer points here at some point, and it just doesn't become worth the argument. But hopefully you get the idea that regardless, quantity demanded just refers to a specific point on the line, whereas demand refers to the whole line. And so when you're talking about percent change in quantity demanded, you're really talking about even though the whole line has moved because demand has changed, you're at a different point on that line still. And that point is still, you could argue, quantity demanded at that particular price, even though the whole demand curve has shifted. You're at some point on that schedule. All right. So again, you have wage elasticity of labor. You have elasticity of savings. Right. And you can see those. Those are always good ones. Elasticity does not necessarily relate to typical supply and demand curves, but again, they're kind of wandering off into the tall grass for me. The idea of elasticity is a really critical and important idea, and it shows that not all demand and not all supply is equal. And it's almost, almost always comes down to budget and price and money. So I don't want to sit there. Again, here's a nice abbreviation or summary, especially for these two. You won't need to be doing these, although if you have an interest in that, you might want to take note of that too. But these are the two that on this one you're going to need. So you're going to need for the test, you're going to need elasticity of demand, elasticity of supply, income elasticity, cross-price elasticity. Okay? And which one is which. So you definitely want the formula, but you also want to know that if it's negative, it's inferior. If income elasticity coefficient is negative, it's inferior. If cross-price elasticity is negative, it's a complement. If the cross-price elasticity coefficient is negative, it's complementary. Positive is substitute. All right? So, all right. There's one other way that we talk about it when it comes to elasticity of demand that you need to know. You'll also need to know this. And this is known as the total revenue rule. All right? Total revenue is very simple. It's just price times quantity. Don't overthink it. Total revenue is just price times quantity. Okay? So, if price, they make this a lot more confusing than it needs to be, in my opinion. It's really a lot more simple than this. If price rises and total revenue falls, or if price falls and total revenue rises. In other words, if price and total revenue move in the opposite direction, then you have elastic demand. If, on the other hand, they move in the same direction, price rises, total revenue rises, price falls, total revenue falls, then you have inelastic demand. Okay? And of course, if the percentage rise in or fall in price is exactly offset by the exact same amount of fall or rise in total revenue, then it's unitary. Okay. All right, so that's an important idea. Just remember what I was saying. If they move in the opposite direction, elastic. Price and total revenue, those are the two things you need to know. Price and total revenue. If you can find those, then total revenue is just price times quantity. And what that means is if they move in opposite direction, it's elastic. If they're moving in the same direction, as price rises, total revenue rises. And you may think that as total revenue has to rise. If you increase the price, you're multiplying Q by a larger P. But remember, law of demand says that as price rises, quantity demanded falls. So even though you're multiplying your total revenue, you're multiplying Q by a larger P, you're multiplying your larger P by a smaller Q. Right? So keep that in mind. And at some point, remember, elasticity is going to vary, even though it's a linear function in many cases for our simplified version. It's not in real life, of course, but many of our demand curves are nice linear or just simple lines. It does not mean that elasticity is constant over that whole line, because it is absolutely not, for this very reason. At some point, the law of diminishing returns is going to set in. You increase price too much, quantity is going to fall so far that total revenue is actually going to start coming down. Okay, and that's what that's a reference to. All right. How would a technological breakthrough in aspirin production impact the market if it were inelastic? In the case of an inelastic market, you'll notice how that demand curve is pretty steep on the left. So this improved technological breakthrough is going to affect supply. It's going to increase supply. So you'll notice that increase in supply meant that they could make it for a lot less, but they're not going to sell that much more of them, right? Quantity did not change by that much. How, on the other hand, in cases where it's pretty elastic, where it's pretty responsive to a change in the price, this improvement is not going to affect price much, but it's going to affect quantity a lot. This is a general application of how we talk about elasticities in economics. Okay? What happens to the housing rental market? When there's a boom in apartment production, suddenly the supply of apartments went right up. What if demand is elastic? What if demand is inelastic, right? And so, again, elasticities are often lower in the short run than in the long run. And sometimes it can be difficult to change quantity demanded in the short run. Easier to change in the long run, to be sure. Almost always, right? And elasticity demand for energy is somewhat inelastic in the short run, but much more elastic in the long run. You might be willing to pay higher prices because you got your demand for energy is not going to change much. So changing the price of energy is not going to necessarily affect demand in the short run. But eventually you're going to find cheaper alternatives. It may go and install solar panels. May put a wind farm on your backyard. I don't know. But somehow or another you're going to start finding less expensive alternatives to that. Okay? All right. Long run versus short run. Impact supply. Again, certainly worth exploring that, but for time's sake, I'll let you do that on your time. I don't ask a lot of questions. I don't think I ask any questions about that particular issue, but it is an important idea. You might see it in your homework, for example. Tax incidence, on the other hand, is kind of important. And what we mean here is, right, I think I've already told you that corporate taxes are little more than a backdoor tax on your consumption. It's just a politician's way of increasing taxes, taking more money away from you. Because it does not matter why it costs. What it matters to make a good or service available to you, every dollar has to be recovered. But there are some exceptions. Again, remember, if you don't have a lot of competition and the good, is relatively inelastic, then um, when they raise taxes, they might not pass as much on to you, or they may be able to pass even more on to you, I should say. If you're talking about highly elastic demand, where you change the price, coin demand is going to fall a lot, you might have to suck it up and absorb some of that, or go out of business yourself. There's just no way to compete, all right? And that's the problem. And again, elasticity helps you kind of see exactly who absorbs most of that increase in tax, right? Is it the company or the consumer that's going to have to pay? The producer or the consumer, right? So when demand is inelastic and consumers are not particularly responsive to a change in the price, coin demand reduces only modestly when the tax is introduced, right? So adding tax to cigarettes does not necessarily change coin demand by all that much. A little bit, but not that much, right? If sellers don't have any alternative than to accept lower prices for the business, then it's not going to have a huge effect on equilibrium quantity, right? But it will take away from producer surplus. It will take away from producer surplus, right? Wow, that was quick. That to me is the big thing you need to know, is that that tax, if it is elastic demand, then they can pass more of that on to the consumer, and there goes your consumer surplus is going to fall. So keep that in mind, right? We talked about surplus in the last, and there's our review. All right. Thanks, folks. I think we got through this fairly quickly. I did not wander off too far from the beaten path. So always good. Sometimes I do, sometimes I don't. We'll just play it by ear. Regardless, folks, have a wonderful day. See you when we start covering Module 6. This is the end of Unit 1. Module 6 picks up with some macro topics, and so we will begin that after you take your Unit 6 test, or Unit 1 test, excuse me. All right, so that's the end of Unit 1. Making steady progress. All right, best of luck. Be safe. Be kind. Thanks, everyone.